single day I'm gonna make something great. That's my way. Every single.
Hi everyone, this is VenKaTesh Panyam, your physics dude. In this video, I am going to explain an interesting what called as the topic today. So, have you ever wondered by looking at this glass why the base of these glasses are made heavier? So, we'll answer this question today, and I'm going to do one more experiment. And see, I have a box containing a different size thermocol balls. So what I'm going to do is I'll shake this. When we shake this box containing different what called as size thermocol box, so what we observe is when we tap it like this, you find that all the thermocol balls which are very small will settle down. The ones which are bigger in size, they'll go up. So what is the reason? Why always the small balls are going down and the heavier ones are coming up? Let's do one more experiment. Here what I'll do is I'll mix bigger objects like some meal makers or something. So I'm just adding to it. Now again what I'll do is, so now I mix these meal makers which are lighter and bigger than thermocol balls, and I'll do the same experiment. So again, if you just shake it well and you observe that when we tap it like this, so these meal makers will come up. You can find them, all the meal makers are still on the top, but still we find thermocol balls are going. So why these meal makers are coming to the top? That is one more. I'll do one more experiment with the same thermocol, this. Now I'll take some rice. I'll add some rice to this, and then I'll add a few thermocols. Not thermocol, sorry, these meal maker balls. I'm adding these meal maker balls. Now you see, when we mix them, what called as, now we find that again I am just shaking it. So when we shake it, see, we find that the rice will go down, but the meal makers still come up. Why the rice is coming up, going down, and the meal maker balls are coming to the top? So what phenomenon is behind all these things? Yeah, you can do one more. You just fill a basket or a bucket with a different sized what called as potatoes, and when you shake this what called as bucket, and you find that the bigger ones will come up, all the small ones will settle down. So it is a very common thing we all observe. So when we add different sized objects, so why always the smaller ones will go down? Suppose you take a beaker, add small pieces of pebbles and add sand. So sand, when compared to that each pebble, the sand grain is very mass is very small, but all the sand will settle down, and why these pebbles will come to the top? So what principle is behind this, and why it behaves like that? So let me answer in this video. But before that, if you really want to know the answer, yes, please subscribe my channel if you really like my content, and please share with your friends, and don't forget to click the bell icon for more updates, and don't forget to leave your comments. And every video, remember, those comments will really help me for doing better things. So you really enjoy this video, right? Let's discuss what is the real reason behind it. Yeah, now let's see the real reason behind it. So first of all, you should understand on what factors the stability of a body depends. See, whenever you take a pen, if I place the pen horizontally, the pen is highly stable. If I keep the pen in a vertical position, the pen is not stable. What is the reason? Because For this pen, this is the point where the entire weight appears to act. That point is called center of gravity. So when it is laying on the ground like this along horizontal, so this is the height of center of gravity. The moment I keep the pen in the vertical position, this is the height of center of gravity. That means the moment you keep it in the vertical position, the height of center of gravity increased. So an important point we should understand is stability inversely proportional to height of center of gravity. Higher the height of center of gravity, lower the stability of a body. And again, the potential energy, we all know that potential energy nothing but mgh. Here h is called height of center of gravity. So higher the height of center of gravity, higher the potential energy, and thereby stability is less. So a body having more potential energy will have less stability. So center of gravity is the reason for all these things. Now let us come to the first one, where I explained about the thermocol balls. So if you look at thermocol balls of various sizes, when we mix a different sized thermocol balls and you shake this container, what happens? See, the system want to have more stability. Every system want to have more stability. How can it get more stability? As I said, stability of a body inversely proportional to its potential energy. Stability of a body inversely proportional to its potential energy. So when the potential energy is small, when the height of center of gravity is small, so when we shake it, all the small sized balls will settle down. Why these balls will settle at the bottom? Why? Because when you shake them, they'll occupy all the nooks and corners of the bottle. That means the gaps will not be there. And that's the reason why more mass will settle at the bottom. The system want to have minimum potential energy, that means minimum height of center of gravity. The heavier balls will go to the top. So when you take the heavier balls like this, so what happens for this entire system of this thermocol balls, somewhere the height of center of gravity lies at this point. So that means more mass is at the bottom when compared to higher. So when smaller bubbles, this thermocol balls settle at the bottom, the system will have less height of center of gravity, less potential energy, more stability. We'll take one more example. In this, there is a glass of water in which I mix some sand. If you look at, the sand is settling down. Why the sand settles down? If you look at here, when compared to water density, the density of sand is more. So more mass is concentrated here. Again, the center of gravity, if you look at this bottle, suppose let's take one more example. Suppose if I take one glass, this is a glass, and if I fill only with water, this glass is filled with water, say up to this level exactly. For this one, this is the point at the midpoint exactly. At the midpoint, there is center of gravity. But since I mixed with what you call as sand, more mass now concentrated at the bottom of this glass. So now if you look at the center of gravity will be somewhere around here. So when compared to this only water, when sand is mixed, the height of center of gravity has decreased. So that means here this is having less potential energy. Potential energy is what you call as a lower here. That means height is less when compared to this one. So higher the potential energy, less is the stability. Less is the potential energy, more is the stability. So in this case, height of center of gravity is less. So this has less potential energy when compared to this. So it will have more stability. So when compared to this glass with only water, a glass in which some sand is mixed to it will be more stable because the height of center of gravity is less. Now again come to this a bucket I said filled with what we call it as potatoes. The same logic goes. If you look at this bucket contains a different sized what we call it as potatoes. Some are big, some are small. Suppose if you give a what we call it as shake to it or you shake the bucket, the same logic goes. All the smaller potatoes will settle down. So why only these will down? Because they'll occupy every point. If there won't be much spaces, and they'll fill all the nooks and corners of the bucket, and the bigger ones will float on the top, so that more is the gaps in between. So the system again will have less height of center of gravity, less potential energy, more stability. The same logic goes to the wine glasses. If you look at a whiskey glass or any glasses, they are usually provided with heavier bases. They usually placed with heavier bases. Why? Because so that the center of gravity height will not increase much. So their center of gravity will be at what called as at lower heights. It will have more stability. That means even if the table on which it was placed, if the table was shake or disturbed, this glass will not fall. Why? Because its base is heavier. So height of center of gravity is very small. It will have more stability. If you take a glass with a very thin what called as base, if this glass has very thin base, definitely this has more tendency to tilt when compared to this glass because its base is lighter. So I hope you understood the real reason behind why smaller thermocol balls will settle down, or when we discussed about even that rice, why the rice just like sand. So smaller grains will settle down so that they'll occupy every corner and the height of center of gravity decreases. I hope you understood the real reason behind what we call it as these thermocol balls, why they go down, and I wish you happy physics learning. Thank you. Thanks for watching. Hey, I hope you understood the real reason behind it. Yeah, don't forget to what called as share my videos and subscribe my channel, and definitely I'll make more interesting videos in physics. Thanks for watching, and I wish you a happy physics learning. My ultimate aim is to make physics an interesting subject. Again, thank you. Thanks for watching. Thank you.